अस्सलाम वालेकुम सर।
हेलो अस्सलाम वालेकुम। कौन है? आवाज आ रही है? जरा आवाज आ रही है आपको?
जी सर।
एक सेकंड, टैब कनेक्ट करो। तो इलेक्ट्रोलिसिस स्टार्ट कर ही लेते हैं। फिर बाकी ऐसे रीजन आई एम एक्चुअली टेकिंग क्लास टुडे इज कि आई विल बी एब्सेंट टुमारो, ठीक है? अच्छा, दिस वन के तो
अस्सलाम
वालेकुम सलाम। अच्छा, कहाँ गया? सही रिकॉर्डिंग हो रही है। अच्छा, नाउ वी डिस्कस वो द प्रीवियस थिंग वी डिड recap. मैंने भी I haven't sent you the recording for the polyatomic ions and stuff, ठीक है? Now we discussed which compounds were soluble, which compounds were insoluble. So we're going to start with electrolysis now. Okay, the first one. Okay, there are 4 or 5 different types of electrolysis. So now remember, electrolysis is the decomposition of an electrolyte, which is something that has free moving ions. So free moving ions are present in molten electrolytes. Molten means there's no water added; it's just high temperature, and the ions are able to move around. Okay, that is what a molten electrolyte is. And it usually happens at a very high temperature. For example, if I have, so starting with the first one, NaCl. Now you need to know 2 things about, before we start, you need to know a few terms and a few things. The first thing is there's certain elements that are diatomic. So diatomic elements. So which elements are diatomic? There is hydrogen. So the hydrogen atom doesn't exist. It does exist, obviously, but what will happen to it is that it will try to form an H2 gas molecule. Okay, so that's it's always going to be H2 in its neutral state. There is oxygen, which is always diatomic. There is nitrogen, which is also always, if it's a neutral atom, it's going to try and remain diatomic. And then there's the entire group 17, which is diatomic, which includes fluorine, chlorine, bromine, iodine, and then there is one which is very rare, that's astatine. So all of them are diatomic. Then there are a few more terms which need to be remembered, and that's there's a term called reduction or reduced. A reduction is used when something gains electrons. And then there's a term called oxidation. Oxidation is going to be used when what happens when something loses electrons. Okay, so remember reduction, and then you have oxidation. So now we're going to start with the electrolysis of a molten electrolyte. So the first one is NaCl in molten state. The molten state is liquid state. Up NaCl has a very high melting point. If you just Google NaCl melting point, that's I think around 801 degrees centigrade. So the melting point is 801. So that's really, really high. So what happens in electrolysis is that you have, let's say you have a container, and the container is going to have two electrodes. Here, that's one. And let's copy paste this one. Okay, here's my second electrode. And the two electrodes will be connected to a battery. The battery has two terminals. It's got the smaller one is the negative terminal, the bigger one is so you got a negative side and you have a positive side. Here, that is what a battery looks like. These things are known as electrodes. Specifically, the right wala, the one that's attached, it could be the other way around as well. You could have the negative on the right side, sorry, on the left side, and you can switch them around. It doesn't really matter. It's up to you. I said now the thing is that these things are known as electrodes, and this is the negative one is specifically called the cathode. Okay, that's your negative one. And the positive one is going to be known as the anode. So anode is the positive terminal, which is connected to the positive side. So if you pick any cell, it's got a cathode, it's got an anode, it's got a positive side, it's got a negative side. Now the electrolyte, as a one more thing, we're talking about inert electrodes at the moment. So remember this, that inert electrodes are the ones that are not, they're very unreactive. They just conduct electricity. They don't do anything. They don't take part in the reaction. The only purpose is that they're conducting electricity. Inert electrodes are made out of graphite, or if you are rich and you have money, you can use platinum, which is very expensive. So graphite is like the cheaper version that is used. Graphite is not totally inert, which you'll learn later on. When we do electrolysis of aluminium, you'll realize that graphite is not really totally inert. It sometimes is taking part in the reaction. But at the moment, we're going to assume that graphite is completely inert. So you got two electrodes. And then what you have is you have the molten electrolyte, which is NaCl. Now, NaCl has sodium ions and Cl ions. They're all floating around because they're at such a high temperature. They've got so much kinetic energy that they're able to overcome the force of attraction that's keeping them together, and they're completely randomly floating in this liquid. Okay, so all the sodium ions and all the Cl ions are floating around. Now, at the cathode, what happens is that the battery is constantly sending electrons. So there are electrons that are accumulating on the electrode. The battery is constantly sending electrons. That's what the negative terminal does. While at the positive terminal, the battery is constantly pulling electrons away. And so that means your electrode over here is becoming electron deficient because the battery is taking away all the electrons from it. Now, naturally, what happens is that your ions, the positive ions, they get attracted to the negative electrode, and the negative ones, they get attracted to the positive. Opposite charges they attract. Okay, so this sodium over here goes and gets attracted to this sodium. So eventually what happens is that all the ions, they they go to opposite ends. The cathode attracts, as a cathode attracts, so it attracts cations, okay, which is why they're called cations. Positive ions are called cations. Okay, so it attracts positive ions. And vice versa, your anode attracts the positive terminal over here, it attracts the negative anions. Okay, so that is it attracts anions. Which are basically negative ions. I said, but what happens when they get attracted to it? The reduction happens at cathode. You get these ions, they get attracted to it. But then the battery starts, because it's sending electrons, the sodium ions will be forced to gain electrons. So all these electrons will eventually end up with sodium ions. So cations are going to be reduced. You can remember the terminology. The terminology is very important. So your sodium ions will start gaining electrons. So if a positive ion gains an electron, it becomes neutral, completely neutral. And that's what your reaction is at cathode. Uh, and a lot of sodium metal is going to be formed. So you're going to see metallic deposit or shiny metallic deposit forming. Okay, they're going to ask you a lot of questions on observation. So shiny metallic deposit forms. As a similarly, what happens at the other side? The anions are oxidized. They lose electrons. What happens is, because the battery is pulling electrons, Cl minus 1 goes over there, and the battery is pulling electrons from it. So it will lose electrons. So when it loses electrons, when your Cl minus 1 loses electrons, so it becomes neutral because it was negative. That meant it had an extra electron. It had one extra electron. Negative means it had one extra electron. But then what happened is that the Cl atom neutral is formed and the electron is lost. Okay, is this clear? ये clear है? Zara, Zainab, Rania, is this clear? Nabir, is this clear?
Yes.
Acha, but over here there is a problem, which is that Cl over here was a diatomic atom, element. Cl will always exist as Cl2. It will not exist as Cl. It will not exist just as Cl. It has to exist as Cl2. So the way that is done is that, I mean, for Cl2 to exist, there should be two Cl ions. And those two Cl ions would lose two electrons. And they'll form two Cl atoms, which will join together to form a Cl2 gas molecule. So this is what your equation is going to be. Okay, that's what your actual equation is. Okay, so over there, that's sodium ions turning into sodium. And over here, you've got chlorine gas that's forming. Now, remember, if you know what a chlorine gas looks like, it's a greenish yellow gas. Okay, Alex, and I'm going to write this down as well. So a greenish yellow gas is formed. So it's kind of pretty straightforward, which is that that you have cathode, which is the negative terminal, which does what? It attracts positive ions. All the positive ions get attracted to it, and because the negative terminal is the one that's sending electrons, so they're supposed to gain electrons over there. So your sodium ions will start gaining electrons and they'll become neutral sodium atoms, right? That is known as reduction because they gain electrons. Reduction is gain of electrons. At the anode, the negative anode, they attract all the negative. So at the positive anode, they attract all the negative ions, which are your anions. Battery is pulling electrons, so they're forced to lose electrons. So your Cl minus one would end up losing electrons, and it will become neutral in this way. But Cl was diatomic, so that meant that it will exist as two Cl atoms joined together. So you're supposed to have two Cl ions, and they're going to lose two electrons, and they'll form two Cl atoms, and they will join up to form Cl2. And remember, always, kid, chlorine over here is a greenish yellow gas. So, ठीक है, is this clear? NaCl molten, is this clear?
जी सर.
So, Sagara, we'll just do a couple of more, right? So I'll just copy this. TCS go. So I won't go into detail. What you need to learn is how to write the equation. That is something that's highly important. So we'll do the second one, which is, so here's the same diagram. I mean, the diagram pretty much remains the same. And इस सारे को हटा देते हैं. So I guess this. So I'm going to do MgO. Magnesium oxide, and that's liquid. Okay, so I'm going to do MgO. Now, इसको copy करके side पे रख लेते हैं, because I would. 1 second. As if we would need this always. So I'm going to do MgO liquid. It's going to have Mg, which is group 2, so that will be +2. I'm just going to draw 1. Okay, let's draw 2. And it's going to have oxygen, which is group 6. It's -2. Now, who's going to gain electrons? It's obviously the cathode is the one that's sending electrons. The electrons will eventually end up with the negative cathode will attract the positive Mg, and Mg will be forced to gain electrons. So what will be your reaction? It's going to be Mg +2. So it needs how many electrons? It needs 2 electrons. And it will eventually become Mg. Mg is a metal. So again, what you'll see is you'll see a shiny, metallic, grayish deposit. Yeah, that's what your observation. Remember, when he's asking for observation, that means what you're going to see. If he's asking for the equation, he's going to tell you he's looking for the equation. So on the other side, what's going to happen on the other side? The positive side, the anode, all the negative ions are going to get attracted to it, and the battery is going to pull electrons away from it. So if I write the equation for that side, it's oxygen -2. It's got 2 extra electrons. So oxygen -2 will lose 2 electrons. So it's going to become neutral. But again, over here, the trouble is that oxygen over here is diatomic, which means there got to be 2 oxygen atoms and they should be joined together. So you would have to double it. It's going to be 2 oxygen ions, and the 2 oxygen ions will be losing in total 4 electrons, and then they'll be forming 2 oxygen atoms, which will join together to form O2 gas molecules. So that now is the equation that's going to be happening at your anode. And that's what your equation is at the cathode. And oxygen gas is a colorless gas. So what you'll see is bubbles of colorless gas forming. And so bubbles of colorless gas are forming over here. And if you know the test for oxygen gas, the test for oxygen gas is that it relights a glowing splint. I mean, you introduce a glowing splint, it will relight. So if you want to test out the oxygen gas, that is exactly what's going to happen. Okay, and let's do one more. I said one thing that you have to remember is that don't look at the formula. All you have to, I mean, you have to be careful about is what ions are present in the solution in the liquid form in the container. So I'm going to do a third one. And let's say this is let's do the third one. And let's say this is magnesium nitride, which is Mg3N2. And so one thing you have to be careful about is simply ignore the formula of what this is. I mean, doesn't really matter what this is. What you need to know is what are the ions? It's Mg and N. Those are the two ions. This is just crisscross, and they've found out the formula. We don't care about the formula when you're doing electrolysis, because in molten state the ions will not be together anymore. The two ions that you have is Mg, which is +2, and let's have two of them. And the other one is nitrogen, which is in group 5. Group 5 will have a charge of, it will have a charge of -3. Let's draw one more. So who's going to gain electrons? Again, you got no choice. Mg +2 is the one that's going to gain electrons. And you're going to write the equation, which is Mg +2. So it needs 2 electrons. And it's going to become Mg. And the other one, who's going to lose electrons? There's no choice. N -3 is the one that's going to lose electrons. And you're going to write its equation. So N is -3. It's going to lose electrons to the battery. So it will become neutral. And it will lose a total of 3 electrons. But again, the issue is that this N -3 or this N over here is diatomic. It's not going to exist as a single atom. So you have to double that. So there's going to be 2 nitrogen ions. And together they will lose a total of 6 electrons. And they're going to form 2 nitrogen atoms, which will join together to form the diatomic N2 gas. So that is what your final equation would look like. Okay, so there is reduction on the right side. And I'm also going to write that. This over here is reduction. And losing electrons, that's oxidation. And again, the observations, it's going to be a metallic deposit on this side. Magnesium is a metal. On the other side, you're going to see colorless. Nitrogen is the 78% air that is around you. That's nitrogen, which is colorless. So colorless nitrogen gas is going to be formed on the left side, which is the anode. Okay. Clear है? So molten electrolyte, is that clear? ये बात मेरा जरा सारों clear रानिया
जी सर
या ठीक है. अच्छा अब so that is molten electrolysis. Now before we start, इसको save करके रख लेते हैं so we don't have to redraw this. 1 second. So now the next thing is that is the electrolysis of aqueous solutions. Aqueous solutions are when some ionic compound is dissolved in water. So it's got to be a soluble ionic compound. Aqueous electrolyte solution meaning electrolyte. I mean, when you use the term electrolyte, that means it's going to have free moving ions. I mean, solution could be any solution. It could be a sugar solution, but that's not electrolysis. So I'm going to copy this. Pretty much the same thing will happen. You get the same electrolysis diagram. Now, so let's try and do the first one, which is NaCl aqueous. Okay, so we're going to do NaCl aqueous. Now, the difference is that NaCl aqueous is going to have two ions. One of them is going to be sodium ions. The other one is going to be Cl minus 1 ions. They'll be floating around in water. But the thing with water is that water weakly ionizes. So whenever you have water, what also happens is that you have, so whenever you have water, water ionizes and produces H plus 1 and OH minus 1 ions. So it produces these two ions, H plus 1 and OH minus 1 ions. So now your solution is a bit more crowded. It's got a few more ions. It's going to have H plus 1 and it's going to have OH. Not a lot because water, not all the water molecules, they break down. Some of the water molecules will break down and they produce H plus 1 and hydroxide ions. So your solution is a bit more crowded and you got a larger variety of ions present. तो यहाँ पे क्या होता है कैथोड पे H plus 1 and Na plus 1 ions are attracted to cathode because now you've got two positive ions. Same thing on the other side. You've got OH minus 1 and Cl minus 1 ions. They are attracted to your anode. Now the thing is, you've got H plus 1, Na plus 1, and the electrons are coming in from the battery. The trouble now is you have to decide who gains electrons because one of the two ions has a stronger attraction for electrons. Maybe both, I mean, maybe the electrons that are coming from that side might be gained by Na plus 1 because it has a stronger attraction for electrons, or vice versa, it might be gained by H plus 1. So how do you decide who out of the two gains electrons? I mean, that's what the question is. So who gains electrons out of the two? And the answer to that is that you would have to decide that by looking at the reactivity series, which is this one. Here you got carbon, Zn, Fe. Au and platinum. So you would have to look at the reactivity series. I'm going to write the names of all these compounds. It's this one is potassium. Then you have Na, which is sodium. You've got calcium. And then there is Mg plus 2, that's obviously magnesium. So all these ions have different tendency to gain electrons. This one is aluminium. So we can ignore carbon for the moment. Zinc is plus 2. Always remember zinc is plus 2. Iron over here, that is plus 2 as well. You've got tin plus 2. This is lead. Then there's hydrogen. You got copper, which is obviously just copper. This is mercury. you've got silver, and then finally you have gold and platinum. This is +1 as well. This is +1. So all of them are +1. So anyways, you've got this reactivity series. Now, when it comes to ions, the more reactive ions are the ones that are right at the bottom. So the ions at the bottom are the ones that will gain electrons. Basically, the ones at the bottom are the ones that are unreactive. They like to gain, they don't like to form ions. Platinum doesn't like to form ions. It likes to gain electrons. नहीं नबीरा वो अच्छा उस पे मैं आता हूँ. अच्छा, so right now at this point you have to remember that in the reactivity series, the bottom ones are the ones that really like to gain electrons. The top ones, potassium is very reactive. It likes to lose electrons, but it doesn't really like to gain the electron back again. Platinum is very unreactive. It doesn't like to lose electrons. So if it has turned into an ion, it would love to get that electron back. So keep this in mind that when you're deciding who's going to gain electrons, whether it's sodium or whether it's hydrogen, and I'm going to mark those. So you've got sodium over here and you've got hydrogen over here at the bottom, right? Then out of the two, it's the one that's at the bottom that's going to gain electrons. So between sodium and H, who gains electrons? It's going to be H+1 that will end up gaining electrons. And it will become neutral. And ab Nabila, yahan pe, why would I double it? Because I told you that some elements are diatomic. So H will never exist as a single atom. They would be two H's and they should be joined together. So I would have to double this. They should be 2H+1 and they should be gaining 2 electrons and they should be forming 2 H's which will join together to form an H2 gas molecule. So in this case, in aqueous solution, so I'm just going to summarize this. In aqueous solution, there was Na+1, there was Cl-1, but there were two ions coming from water as well, H+1 and OH ions. So your solution was a bit more crowded. Your electrons were coming in, but one of the two ions has a bigger attraction for electrons. And you got to remember, it's always the bottom ones that have a higher attraction for electrons that really like to attract electrons. So if it's sodium and H, you're going to select H. H is the one that's got a higher tendency to actually attract electrons. Nothing will happen to sodium. Your H ions will turn into H2 gas. So what you'll notice is you'll notice bubbles of H2 gas forming over here. So you'll see a lot of bubbles forming, but nothing will happen to sodium. So colorless gas bubbles are formed. And remember, if you want to test H2 gas, the test for H2 gas is that it produces a squeaky pop sound when you burn it. Okay. But the important thing is you got to remember the reactivity series. But is this clear, this part? You clear a cathode wala part, is this clear?
Yes, sir.
So, how do you remember the reactivity series? That's another issue. कोई बात ज़रा याद है कि how did we remember this?
Kashif Nekar only. After very Ghazali from Pakistan, cute, honest, and amazing person.
सर कोई और decent बना लेते हैं. AG, AU, PT. अच्छा, you can create a mnemonic अच्छा, I'm just trying to create a mnemonic based on ChatGPT, ठीक है? One second. ChatGPT is making weird mnemonics. I mean, the easy way to remember this is just keep repeating K, N, S, C, M, G, L, Z, and Fe. S and PB. Asian kings can't make a zealous investment for success. ये तो सारे weird है. अच्छा, anyways, try thinking. Next class, I'll try and make up a mnemonic out of it. ठीक है? Uh, and I'll tell you, ठीक है? But you got to remember this. This entire C is K, N, S, C, M, G, A, L, Z, and F, E, S, and P, B, H, C, U, H, G, A, G, A, U, and PT platinum. Uh, you got to remember this. And always when you have multiple lines at cathode, then you're going to look at this. The ones that are at the bottom, they're the ones that really like to gain electrons. Achha, on the other side, what you have is कि ये side तो होगी. On the other side, again there's an issue, which is achha, we're out of time, so the other side thing we can't really complete right now. Let's stick to this. ठीक है, ये मुझे बताओ 100% clear है सारों को.
जी सर.
ठीक है. Or just remember, be careful with diatomic molecules where you have to double. Okay, we have to double because you have to have two hydrogen atoms so that they can join up and form H2. Okay, Nabila, that was the same reason why we doubled the nitrogen thing as well over here. You had N minus 3. Originally, you had N minus 3 and it was losing 3 electrons and it was forming a neutral N atom, but it was diatomic. So you have to double it. It's 2n minus 3 n's. They would lose 6 electrons. It's going to produce 2 n's, which will join together to form N2 gas molecule. So ठीक है, let's continue with this. ठीक है, next time हम continue करते हैं. We'll leave this at this point. ठीक है, कोई question तो नहीं? Any questions?
No, sir.
चलो ठीक है.
Allah Hafiz.
Okay, Allah Hafiz.